You okay? Sorry to hear that. So yesterday we talked about if you have some h of x, which is a product of two other functions. Functions. And if you want to take the derivative of this side, you get h of x, h prime of x. That's true, right? What did I get on the other side? It was f prime times g plus f times g prime. Ta-da! And this, friends, is the product rule. Okay, can you stop squeaking the black chair? That thing's annoying. Oh, I hate that chair. I think I'm going to throw it in the garbage pretty soon. All right. So you're like, screw 'em. Do you mean if you had like 5x squared? I'm like, no, silly goose. I don't think I need product rule for that one. But if I had 5x plus 2 times 3x squared minus 7x plus square root of x, something like that crap. I don't want to FOIL that out. I could, but I don't want to. So I'm just going to take the derivative thusly. So what is the derivative of this first part? 10x times the second function plus the first times the derivative of this mess, yes? Which would be 6x minus 7. Oh no, that's x to the 1/2 power, yes? How do you take the derivative of x to the 1/2? So it's 1/2 x to the minus 1/2, aka 1/2 square roots of x's, yes? Ta-da! Is that far enough? Do I have to go any further? Well, listen, it depends on what you want to do with it. If you're just making cookie dough, do you have to cook it? Well, I guess you don't have to. I feel like you probably should go a little further than this. Please be aware that later on we're going to find out where this thing equals 0. Alright? Now, some of the really ugly ones, like this one, you can't solve algebraically. Well, that sucks. No, it doesn't. It's even better. Because then I can just graph them and find out where it equals 0, for instance. Does a computer care what it looks like when you graph it? I feel like it doesn't. If I want to take a derivative again, what if I want to take the second derivative? Because later on we will be doing that. Yay, I can take the derivative of that. It might behoove you to combine them if you're going to take a second derivative. Okay? I'm just saying. So, at this point, it's not wrong, but don't be lazy. Let's go ahead and FOIL it out and see what we get, shall we? So that'd be 30x cubed minus 70x squared plus 10x to the... What are you guys doing over there? What are you doing? What are you doing? What's going on? X to the 3/2 plus 30x cubed. Oh, that's cubed. Minus 35x squared. Plus, check it now, 5x squared over 2 square roots of x. But isn't that x to the 3/2? Yes, it is. Thank you. I swear. Right? And then if I do 2 times that plus 12x minus 14 minus, and you could write it in a number of ways, but it's going to be just 1 over the square root of x, I guess. Probably the easiest way to write it. I don't care. So that's going to be 60x cubed negative 105x squared plus 12.5 x to the 3/2 plus 12x minus 14 minus 1 over the square root of x. Ta-da! Again, not really solvable by any methods that we know how to do very well. So if I was going to solve this one where it equaled 0 or something, I'd have to graph it anyways. Okay, if I want to take another derivative from here, pretend that was just a function and take a derivative of it, I could do it easily, yes? Easily. Yeah. So, again, all we're doing is practicing taking derivatives. That's it. That's all. Nothing to it. Now, products are very straightforward. Quotients aren't a whole lot worse, but they're not real good either. Now, Mr. Grimm has a question. If you saw this guy in the dark alley, Brooke, would you be scared of him? The answer is no, of course I wouldn't, Mr. Grimm. It's ridiculous. It's not even a hard problem at all. Right? It's not. And so here's my question to you there. If that's true, if you're not afraid of that one, which, by the way, you shouldn't be afraid of him, what is the domain of this function, Brooke? Well, x cannot equal negative 5. That's 100% correct. You are a genius. Now, what happens at negative 5? Whole asymptote. What do we got? You do know. Please do not say I don't know. I'll wait for you. Well, I feel like if it was a whole, I could factor it out. And I don't think I can factor it out. So therefore, it must be an asymptote, yes? Now, what do we know about the derivative at an asymptote? How fast is it, for instance, if it looked like this, how fast is it going up right then? It feels like it's an infinite amount that it's going up fast, yes? If it was like this, you'd be like, well, on one side it's going up, this side it's going down. So the limit wouldn't exist, would it? Right? So in a minute, what we're going to see here is this function is what we say not differentiable at x equals negative 5. And we're going to see why that is in a minute. Because in a minute, guess what's going to be in our denominator? Guess what's going to be in our denominator? I don't know exactly what it's going to look like, but there's going to be an x plus 5 in my denominator when I'm done. Okay? It's still going to be in there. In other words, it's not going anywhere. Okay? Again, I don't know what it looks like. Well, that's not true. I know what it looks like. That's a lie. I'm sorry. I lied to you. Please don't hate me. But yeah, I know what it's going to look like, but it's going to be an x plus 5 down there in the bottom. Now, we need a rule. And the rule is this. If you have h of x is some f of x divided by some g of x, h prime is simply f prime of x times g of x. Hey, that looks familiar. It should. But look, watch. Minus f times g prime. So the only difference is subtraction. Well, not quite. Over the bottom squared. What do you... Oh, yeah, okay. I thought you were playing a video game over there.
Video.
I got you. And it looks like a game. How exciting. Now, a friend of mine I used to teach with in high school, or not in high school, the first couple years I taught up in Idaho, he always had this little thing, and it always bothered me, but whatever. He always wrote it this way, low-de high, and he sang it to the children. I will not sing it to you. Low-de high minus high-de low over the square of what's below. But I'm not going to sing it to you, but he would always sing it. What does that mean, Mr. Grimm? Low-de high. It means take the derivative of the high function, which is the top one, times it by the bottom one, minus the top one times the derivative of the bottom one, all over the square of what's on the bottom. Okay, great. And he would sing it, and it was... Just memorize the freaking formula. Notice the top is the same. Notice that the top is the same, except with a minus. Okay? And then just divide out by the bottom square. Okay? Got it? Now, let's go back and do this problem over here. The recipe says take the derivative of the numerator. What is the derivative of that thing? 3 times the bottom plus the top times the derivative of the bottom. What's the derivative of the bottom? Do what now? Oh, thank you, minus. Times the derivative of the bottom, which is 1 all over the bottom squared. Dude, I told you x plus 5 would be down here. Didn't I? I believe I did, Lily. I believe I did tell you that. Now, Lil, let's combine some like terms here. Check it, dog. Yes? Now I have a question for Mr. Olson. Mr. Olson, look at that function right there. Does that function ever equal 0? 14 over x plus 5 squared, does it ever equal 0? I don't know. If it did, check it out, friends. If that were true, yes? Yeah, thank you. Apparently I'm stupid. As someone told me yesterday, there's no apparently about it. I said, okay, thanks. I'm not kidding, that truly happened. That truly happened. Anywho, now, if you have a fraction equaling 0, what part of the fraction makes it 0? The top or the bottom? I feel like the top would have to be 0. Can 16 equal 0? So I feel like this guy never equals 0. Well, doesn't that mean that it kind of has to be always positive or always negative? Or, wait for it, there's an asymptote. Could it switch at the asymptote? Maybe. But let's look at the top. The top's positive, is it not? The bottom is always... Look at the bottom. The bottom is always positive or always negative? Or always positive because it's what? Because it's squared. So this guy is, in fact, it's always positive, isn't it? Yes? If it's always positive, what does that mean about my original function? Is it always increasing or always decreasing? It's always going uphill because the slopes are always positive. That seems interesting. It's always increasing. That's interesting. Interesting. So wait a minute. I feel like on the original problem at -5, we had an asymptote, yes? And check it out. Look at this function here. 3x minus 1. Oh, that's last chapter. Why are you asking me this from last chapter, Mr. Groom? What is the limit as x approaches infinity of this guy? What is the limit as x approaches infinity of this fellow? Well, don't we have to divide by x, Mr. Groom? I feel like we do. We're going to get 3 over 1, aren't we? Right? So, 3. And what do we call this? We call this our... Say it louder. I heard it over there. Horizontal asymptote. Very nice. So you mean to tell me that over here somewhere I have this horizontal asymptote passing through. Yeah, that's what I'm saying. So last I checked, when you head towards an asymptote, you have to go up or down, yes? But you just told me a minute ago that this function's always increasing. So when I come this direction, I better go what? I better go up. So without ever looking at this graph, I have to just kind of know what's happening here, combining the stuff we've already been studying. It looks like this on this side. And what must be happening is either I'm coming down or I'm going up. Well, which is it? It's always increasing, so I better start down here, right? And head up. Am I always increasing? Yeah, I'm headed toward this line. Am I ever going to get there? No. I'm going to get awful close. Ta-da! If you were to graph this in the Desmos.com, come on, open up, you piece of garbage. Oh, there it goes. Just be patient, dummy. Ah! Of course Desmos doesn't show up. Why would Desmos show up? Can't expect Desmos. I only go there every freaking day. What was it? 3x plus 1? Not. It's literally like I drew it. Like I knew what was up before I even, did it. Notice it's always going up. There's your y equals 3 cutting across there. You can put it in if you like. And you're not wrong about it getting awfully close. That's good. Now, Mr. Grimm, there's frequently going to be asymptotes, right? When you have something over something. Yes? It's going to happen pretty regular. Now, for instance, let's try this one. I'm glad he's been channeling me over there. That's good. What? Weird. Okay, before I go on any further, this could have been x squared plus 4x minus 5, right? On the bottom? But of course, when in doubt, you ought to factor it out. I'm just saying. But I did. I factored it out. There it is. So here's my question. What is the domain? X better not equal who? Now, does this top guy factor at all? No, it doesn't. The fact that I can't factor it out and cancel it means these guys are both what? Asymptotes. Now, I'm going to go ahead and rewrite this as x squared, what did I say it was, plus 4x minus 5. I'll go ahead and write it like that, because I think it's going to make me happier in the long run. But here's my question to you. Let's look at the horizontal asymptote of this fellow. What happens here? It's 4x squared over x squared, so it's headed toward where? Zero, 0, 1, 1, 0, 0. It's headed to 4, isn't it? This should be review for us, right? I hope. Right? I hope. I hope. Okay. So let's take the derivative of the numerator. What do I get on the numerator? Well, I get 8x plus 6. Yes? Times the bottom. Minus the top. Times the derivative of the bottom, which is 2x plus 4. Over the bottom. Squared. Couldn't I have taken these guys and squared them too? I suppose it's the same thing. It's the same thing. Literally. Let's distribute, shall we? So that's 8x squared, 8x cubed, you idiot. And then this times that is 16x squared, so minus. And this times this is 12, so it's minus 12x squared. And then this times this is 24x, so it's minus 24x. And then that times that is minus 2x, so it's going to be plus 2x. And that's negative 4, so plus 4. Whew. So we get 8x cubed plus 38x squared. Oops, minus 16x minus 30. And if you combine your like terms, that's a cubed. You get 0x cubes. That's handy. You get 10x squareds. That's handy. And this and that's negative 38x. And then minus 26. That's the numerator over this guy. Right? This is f prime of x. Yes? I haven't asked. What's that now? You mean to blow the bottom out?
Yeah.
I don't think I want to blow the bottom. If anything, I want to factor the bottom back out to from where it came from, maybe. x plus 5, x minus 1. I'm not saying I would, but if I'm doing anything, I'm going to do it this way. Okay? Because then maybe one of these would go into this top guy. I'm telling you right now they don't. But if it did, that'd be Q, but it didn't. So. Now, here's my question to you. If I were to ask you a question here, this bottom is x to the 4th power, isn't it? You see that? If you FOIL it out, it'd be x to the 4th. So here's my question. You have x squared over x to the 4th. What's this thing doing as x gets huge? Is x squared over x to the 4th. What happens as x gets big? This thing is headed towards 0, yes? Now, what are you saying to me, Mr. Grimm? I'm saying to you that our slopes get smaller you see that? As x goes to infinity. Weird, Hannah. I feel like we said a minute ago our asymptote was 0. Yes? Right? So Hannah, it feels like if I have a graph coming down like this or up like this, either one, the slopes in both cases are going to 0, aren't they? Nice. Am I shocked by this? I'm not. Because it's an asymptote. So let's think about this for a minute. We said we have asymptotes where? At -5 and +1. Right? Right. Okay. I got a question for you. Let's go here. Now, what is a number that's just a skosh less than -5? Just a skosh. Maybe a skosh more. 96? I'm just teasing with you. But yeah, any of them would have worked. Yes? Yes? Nice. If a person were to plug -6 into this stuff, right, it would tell me either a positive answer or a negative answer, would it not? Yes. And when I look at that, I'm thinking to myself, well, if it's a negative slope, right, then the graph must be going down, yes? On this side? If it was a positive slope, it must be going up, yes? Well, that's interesting. Matter of fact, well, you know what we kind of need to know? I think it would be kind of cool to know, where is this function positive or negative, wouldn't it? I mean, I think that's going to be kind of a big deal every time. Because if it's positive, my function is going to be going uphill. If it's negative, it's going to be going down. If it's 0, it's just got a minimum or a maximum, yes? Well, let's try it, shall we? Look at this equation right here. If I was to set it equal to 0, we're only looking at the numerator, aren't we? Okay? But hang on. The bottom is always positive again, isn't it? Because it's squared. By the way, that will happen every single freaking time you have one of these guys. Okay? That's not 100% true. That's kind of a bit of a lie. What if the original function was x to the 3/2, Mr. Grimm, and then you squared that, you get x cubed? Yeah, okay. So it's possible it's not, but most of the time it'll be this thing squared, which means it's going to be positive. Okay? So if that's true then, I only really have to pay attention to this numerator. So, I'm going to pretend like I'm in Algebra 1 again. If you saw this in Algebra 1, what would you do? And you're in the teacher's class that keeps an eye on you with your cell phones and whatnot. And what would you do? I think you'd use the quadratic formula. Help me out. What's 38 squared? What's 38 squared? What is it? I don't know. 38 squared is? 1444? Minus 4AC, so it's going to be plus 104, plus 104? To who? Minus 4AC, no, I forgot the 10. Thank you. So it's 40 times that, so it'd be 1040. Oh, that 4.
Yeah.
Thank you. All over 20. What does that number come out to be, Garth? So this plus this is 87 divided by 20 is 4 point. I can't even divide in my head today. 4 point something. So 87.8 divided by 4. I can't even do anything right today. Good enough for government work. This minus this is negative 11.8 divided by 20 is negative a half-ish. Yes? 5 something-ish, 0.5-ish. I'm just going to go with that. I'm going with it. I don't care. This is where we have a slope of 0. Slope of 0. Yes? Wait a minute. I have a question though. That's creeping me out a little bit. Because it feels like if those were my slopes are 0, right? If those were my slopes are 0, I'm going to have negatives and positives on either side of those guys, yes? But wait a minute. If you saw that and you graphed it, you know it must do this, yes? Because it's positive. Therefore, this is the negative 0.5 one, right? And then this is the 4.39 one. So between them we have negative slopes, right? And on the other side we have positive slopes, yes? Right? Right. Okay, Lil. That's where the fun begins, friend. This is where the fun begins. Are we ready for this? I want to look at this one first. This negative 0.5 one. Where does that occur? Well, by George, it occurs right in here somewhere, doesn't it? Now, Mr. Green, is it up here? I don't know. Or is it up here? I don't know. Let's find out. It said to me right here, it said that when I was at negative 0.5, if you're to the left of it, you had a positive slope. In other words, you were coming up, and then after it, you were going down. That makes this guy here a what? It was going up, and now it's going down. It makes it a maximum. Well, now, friend. Which of these would have a maximum? Would it be this one? Or would it be this one? Feel like it'd be this bottom one, huh? It must look something like this. Because again, positive slopes, yes? And then what? Negative slopes. So it's not this one up here. Now, I don't know exactly where it lands at negative 0.5, but if I wanted to, I could plug it in totally and find out what f of 0.5, negative 0.5 is. I don't really care. I want to know kind of what the graph looks like. That's all. Okay? Now, the other one was at where? 4.39? 4.39, right out here somewhere. And notice that it was negative slopes, and now it has positive slopes, yes? Wait a minute. Now, you told me 10 minutes ago, Brooklyn, when we started this problem, that the horizontal asymptote was 0, yes? Right? Well, we did. You literally said that to me. And you said that at 4.39, which is right here somewhere, it's either up here or down here, I'm not sure where it is, we said that it was coming down, and said that this was a minimum, and then it had to keep going back up. Now, if this were true, if it was up here, if it kept going up, how can it get back to the asymptote? That feels weird. You see that? It feels weird. So I know I have to be coming toward the asymptote like this. You see? Or like this. But there's no way to do that if this point's up here, yes? So it has to be down here somewhere. That is, it's coming down to a what? What do we call this point? To a minimum. And then she starts building back up to our asymptote. Oh. But there's more. Now, notice that these guys were all negative slopes, yes? And we know that everywhere, somewhere up here, we had it written down. We said that anywhere when x is less than negative 0.5, they were all negative slopes, yes? Right? Well, let's come over here. If you're over here somewhere, how do I get a negative slope such that this is my asymptote here, and I have an asymptote here? Well, it can't be this, obviously, because those are positive slopes. Ergo, it must be this feller. And again, it's not differentiable here at -5. No differentiable. Also, here at x equals 1. Right? It's also not continuous there, is it? Should we look at the graph? I know you don't believe me. I'm doing it anyways. I don't care. I'm doing it anyways. Screw it. Read me the original problem here. What was it?
It is 10x squared
Oh, fart. 10x squared.
minus 38x.
No, the original problem.
Oh,
Not the derivative. Is 5x squared or something?
4x squared plus 6x.
Minus 1. Which one do you want?
This is the one that's already foiled out.
X squared plus 4x minus 5.
Oh, interesting. Oh, Mr. Groom, you schmucked it up. I did schmuck it up a little bit. Mr. Groom didn't pay attention to himself. Mr. Groom actually wrote it down, then Mr. Groom convinced us all that we were wrong. Where was our horizontal asymptote? Not 0. So, let's try that again, shall we? Same picture, yes, except where does it start? Except it comes up to, it comes down, and then it goes up to, and approaches 4. Nice. And this one starts up at 4. Oh. Alright, so I had it right, kind of, sort of. Mr. Groom, I don't know where this one was. Look at the graph. Oh, it's actually like a little above the x-axis, Mr. Groom. You screwed up. I drew a picture of it. That's what it's trying to do. Okay. If I want to know the exact value, I just grab a freaking calculator. I don't. I want to understand how the pieces and parts go together. You with me on this? Okay. Again, if you look over here on this graph, there's a minimum or maximum here, and there's a minimum there. If you zoom in on it, you can actually see it. That is a minimum. Here we're coming down. We're coming down. Hey, those are smaller. They come back up, and then they grow back up again. That happened to be a min. Now, we could do these all day. They're not very difficult. We got one more. Scream, you've only done 3 examples all day. I know. You're not wrong. Is there anything that the bottom cannot be? Because it's squared. That's right. So, all reals. Wait a minute. If it's all reals, is there any place where it's not differentiable? I don't know. We'll decide in a few minutes. Maybe. Maybe it's not. I don't know. Okay, remember a step function is also all reals. Right? All real, but that doesn't mean it's differentiable at the steps. Yes? So, we'll see. Well, let's see what happens here. So, f prime is 2x squared plus 1 minus what? 2x times 2x minus 7, yes? Oh, you wrote it backwards. It doesn't matter. I just did f g prime. It's fine. All over the bottom. Squared. So that is 2x squared plus 2 minus 4x squared plus 14. See? So there's negative 2x squared. What's the matter? Thank you. Thank you. Excellent. Oh, this is exciting. So this is our derivative. I hate it when it does that. There we go. So f prime of x. Sweet. Yeah. Keep me out of the game, you think? Not going to happen, pal. Ah, but I hate when it does that. All right, so f prime of x is that, and it's not going to work at all. I don't care. Now listen, look at the bottom. The bottom is always positive, is it not? Always positive. Does the top one ever equal 0? Well, I don't know. I don't know. So, right, you piece of crap. Sometimes you just gotta show her who's boss. I'm in charge here, lady. So how you doing? Oh, well, I'm faking it pretty well. Screw that. All right. So, we're going old school. All right. So negative 14 plus or minus the square root of 196 minus a minus. So it's going to be minus plus 16 over negative 4, and so that's 14 and a half ish. I don't care. Don't really tell me. I don't really care. Plus minus 14 and a half ish over that. So that'd be basically 0.5 divided by that, so like negative a small amount, negative like an 8-ish. And if you take this minus this, is negative 28 divided, so positive 7-ish. Okay? All right? That is where I will have 0 slopes, yes? Does this, look at this parabola on top, look at him. He's negative. Meaning he will open down. So if he opens down like so this one is the negative 0.125-ish one, and this is the positive 7-ish one. Okay? So between those values we will have a positive slopes, negative slopes, like so, yes? Notice that there were no asymptotes on this fellow, yes? None. Also, notice that back on the original problem, it was 2x over x squared, correct? Meaning the thing is going to 0 as time goes to infinity, yes? Okay, make sense? So, let me get a clear screen. Sort of. Ah! Alright. So what I want is this. Think about this for a minute. Okay, we know we have a horizontal asymptote of 0. Well, there it is, whatever, okay? We know we have a maximum or a minimum here and a maximum or a minimum there, yes? Negative slopes, positive slopes. This one is was coming down, now it's going up. This guy is a minimum. So somewhere in here it was a minimum. Okay? Oops, a minimum. So I'm not sure what I want to do about that. This one here is a 7 is a maximum because it was going up, now it's coming back down. And then we have negative slopes, but we know that it's coming down toward this asymptote. Are these still negative slopes out here? Yeah, it's still going down. Come back down like so, ish, and then come back up like so. Okay? And that's what our function has to look like. Now, Mr. Groom, if I'm checking my work via calculator on the test, is that okay? Well, listen, you can always check your calculator, but if I don't see work, it's wrong. So what's on top? 2x?
2x
Mr. Groom, it looks weird. Ah, dude, it's there, bro. We zoom in. I bet this minimum is at negative, look at that, 0.14. That's about an 1/8. That's pretty good. And this maximum right there, 7-ish. 7-ish. How to play. Okay? That's what you do when you don't have a calculator. You just kind of go with the old ish routine. It's pretty close. Okay? And then again, notice how it is going down back toward the x-axis again, yes? Yeah. Nice. So, over the weekend, you should be working on, that's what, the third assignment on that page, I think? Is that right? Second assignment. 3.3, which is the second assignment. Well, you know what I meant. Whatever. All right, you do that.